Welcome back to the Explainer. So, last week we started looking into the cold blob. That incredibly stubborn patch of chilled water in the North Atlantic that is just completely ignoring our warming planet. To put this anomaly into perspective, while global ocean temperatures have been shattering all time heat records month after month, the specific patch has actually managed to drop nearly 2 degrees centigrade below its long term average. It is literally a glaring blue bullseye in the sea of red. Well, since our last explainer, the data has just continued to pour in. And looking at what we are seeing right now, we really have to ask ourselves some serious questions about what this data represents for our immediate future. And the core mystery we need to solve is this: is it just a passing phase or a fundamental shift in our climate's heartbeat? Today, we are doing a deep dive into the current status of the anomaly to see exactly what the science is telling us. Part 1: The mechanism. Why it matters. Let's get into the mechanics of this. We are talking about the AMOC, the Atlantic Meridional Overturning Circulation. Basically, you can think of this as a massive global conveyor belt. Now, this beautifully efficient system usually pulls warm tropical water towards north, which plays a massive role in keeping Europe temperate. To really grasp the scale here, you have to realize that the AMEC transports roughly 15 million cubic centimeters of water every single second. That's more than 100 times the flow of the entire Amazon River. And energy wise, it moves nearly a petawatt of heat. This is equivalent to about 100,000 times the energy consumption of human civilization at any given moment. It is the beating heart of the ocean's heat distribution. But right now, that heart is definitely experiencing a bit of an arrhythmia. So, how exactly does a magnificent process like this get disrupted? Well, the disruption begins with the Greenland's ice melt pouring just staggering volumes of fresh water right into the North Atlantic. And because fresh water obviously lacks the salt content of seawater, it's significantly lighter and less dense. Simply put, it refuses to sink. This creates a massive bottleneck. You see, the AMAC relies on that cold, salty water sinking deep down into the abyss to pull more warm water up behind it. Without that downward pull, the entire conveyor belt slows down. The heat that is normally meant for northern latitudes just gets stranded further towards south, leaving the specific pocket of the Atlantic oddly and persistently chilled. That is the exact mechanical sequence creating our cold blob. Part 2: The current status, latest data. Now, what's really fascinating about this latest telemetry is that the anomaly is absolutely not dissipating. While the outer edges of this cold zone do fluctuate a bit, the core of the subpolar layer is remaining remarkably stable. Scientists observing the region are tracking surface temperatures up to 3 degrees Fahrenheit below the historical average for this time of the year. And keep in mind, this is happening concurrently with the rest of the Atlantic basin, recording temperatures well above historical baselines. It's an extraordinary thermal deficit, and it continues to stubbornly anchor itself right in the middle of one of the ocean's most vital circulation nodes. Now, I want to be perfectly clear about something. We are not looking at a total shutdown here. Far from it. However, the data we are getting is definitive. We are currently seeing sustained drops in salinity levels. Why is that so important? because salinity acts as a chemical fingerprint for deep ocean currents. A sustained shift in salinity confirms this isn't just a surface level weather event like a stubborn cold front or an atmospheric block. You know, it's a structural change in the water column itself. The ocean's fundamental heat circulation is being actively and deeply tested right before our eyes. And this brilliantly illustrates what leading climate researchers mean when they say the blob acts as a sentinel. It's a powerful metaphor, absolutely, but an entirely accurate one also. This anomaly is a physical, undeniable indicator of much broader, much more significant systemic oceanographic changes happening deep beneath the surface. Part 3, looking ahead, what to watch. So, what's next? Well, researchers are now focusing their telemetry heavily on the upcoming winter cycle. They are closely watching how the cold blob interacts with the winter storms and deep seasonal cooling. You see, winter is the ultimate stress test for the AMOC. As the ferocious North Atlantic storms rip across the surface, they normally extract heat and cause aggressive mixing, which helps drive that critical sinking action we talked about earlier. Observing how the current reacts to this upcoming season's deep freeze is going to tell us exactly how resilient the AMOC truly is and whether it can actually power through this localized freshwater density issue. Because the stakes here are incredibly high, if the blob expands and the AMOC significantly weakens, it could drastically influence weather patterns across Western Europe and the Eastern United States. We aren't just talking about a slight chill either. We are looking at the potential for brutally harsh, extended winters across the UK and the Western Europe. At the same time, a slowed AMOC means water physically piles up on the other side of the ocean, leading to the accelerated sea level rise right along the eastern seaboard of the US. It could even shift tropical monsoon systems that billions of people rely on for agriculture. We are talking about fundamental sweeping shifts in the seasonal norms across the globe. We are absolutely going to continue tracking these anomalies as the data updates. The ocean is incredibly vast for sure, but these localized signals are becoming impossible to ignore. They are telling us a profound story about the changing hidden mechanics of our planet. Thank you so much for joining me for this follow up. And if you found this breakdown helpful, please consider subscribing to the explainer as we continue to track these shifts. But I'm really interested in your thoughts on all this. Are we paying enough attention to these early warning signs? Let me know down in the comments below. See you in the next one.